Our next speaker is Perry Marshall. He's a business strategist endorsed in Forbes and Inc. magazine and has authored 10 books in 2019. Along with scientists from Oxford and MIT, he announced the world's largest science research challenge, the US $10 million Evolution 2.0 prize at London's Royal Society. He has a degree in engineering and lives with his family in Chicago. Mr. Marshall, over to you. Thank you.
Hello, good day to all of you. I'm very glad to be here. Welcome, and I'm going to share my screen. And this is a very important topic, and I want to start with a story. This presentation is called Biology Transcends the Limits of Computation. Is very much in the spirit of the conference that you are hosting here. And conflict of interest disclosure. I have a $10 million prize for the origin of information. This was announced at the Royal Society 3 years ago, and we are searching for a patentable process that produces codes from chemicals. And this starts 18 years ago with a conversation I had with my brother. I want to give you some background of how is it that an engineer and business consultant came to be giving a talk on this topic. And Brian and I are both from a Christian family. Our father was a pastor. And when we grew up, I went into business, and Brian got a seminary degree, trained to be a pastor, and then ended up in China as a missionary. And we were in this bus, and I was visiting him in 2004, and we were having a conversation, and he was explaining to me that I don't believe this Christianity stuff anymore, and I'm done with that, and I'm gonna move back home and stop being a missionary pretty soon. And we got into an argument. And I said, Brian, look at the hand at the end of your arm. This is a nice piece of engineering, and I'm an engineer, I should know. You don't think this is an accumulation of random accidents, do you? And he said, hold on. He said, if you have 1 million falcons for 1 million years flying around, one of them's going to accidentally get a DNA mutation that improves its vision, and then it's going to outhunt the other falcons, and the falcons are going to get better. And you don't need any kind of intelligence or any kind of design or plan. All you need is time and natural selection, and you're going to get better falcons. And that explains how you got your hand. And there is no design in the universe. And I thought about what he said, and the first thing I thought was, I cannot think of anything that I have learned in more than 20 years of engineering that would verify that what he just told me is true. I've never seen that happen. But I also know that a whole bunch of biologists would agree with him and not me. So somebody's missing something somewhere. And maybe I'm wrong, and maybe there's a bunch of stuff I don't know. And because I'm an engineer, and because I've done engineering for so long, I know there's some things in science that are very, very strange. And I might not know everything. And so I'm going to stop arguing with my brother right now, because we're just making ourselves miserable anyway. And when I get home, I'm going to get to the bottom of this, and I'm going to let science make this decision for me. And I'm going to not approach this as a religious question. I'm going to approach this as a science and engineering question. Can you really get a hand without some kind of a design going on? And I went home and I hit the books, and I started buying books like crazy. I started reading scientific papers. And the presentation that you're seeing today is where I'm at 18 years later. So that's the background behind how this happened. And to the extent that science can prove anything, I am going to show you today that the design problem in biology has not been solved. In fact, the design problem is really the cognition and consciousness problem, and it's central to biology. And so let's start with Erwin Schrödinger. In 1943, he gave a talk, and he wrote a book in 1944 called What is Life? And he used the term negative entropy, and he defined it as the force that creates order from disorder. And this is one of the primary unsolved problems in biology, because negative information entropy is the opposite of noise. It converts uncertainty into certainty. It converts chaos into order, which is the reverse of standard thermodynamic entropy. The next unsolved problem right behind that is the origin of the genetic code. And this is a diagram from my $10 million prize specification. And we are looking for a chemical process that will generate an encoder, a message, and a decoder without anybody cheating or having to design it. And DNA transcription and translation are identical to this. And so every cell in its process of reproduction executes a communication process just as you see here. And nobody knows where this came from. And so so chemicals in biology don't control information. Information controls chemicals, as exemplified by the creation of amino acids in the genetic code. And the rules of codes cannot be, the rules of codes cannot be derived from the laws of physics, which Hubert Yockey explained in 2005. Number 3 is the problem of evolution. And many people make it sound as though we've solved evolution because we understand natural selection. That's not true. The real mystery of evolution is in Barbara McClintock's experiment where she damaged corn DNA. The corn plant rearranged its genome immediately and successfully without having to do thousands or millions of failed trials. And at UCLA, John Torday found out that if a granddaughter is born from a smoking grandmother, she inherits, I'm sorry, let me rephrase that. A granddaughter inherits asthma via epigenetics from a smoking grandmother who could be dead and who she might have never met, because the epigenetic response to the smoking is transmitted through the egg to the daughter and to the granddaughter. And so we see that in evolution, organisms anticipate the future and evolve proactively. And nobody knows how this is done. We know about many mechanisms. We know about symbiogenesis and transposition and epigenetics and horizontal gene transfer, but we don't know the decision-making process that organisms use to make these changes. The fourth unsolved problem in biology is consciousness and agency. And one of the most basic examples of this is sexual selection. Animals choose mates based on conscious experience. And so therefore, conscious experience is an intrinsic part of evolutionary biology. James Shapiro at the University of Chicago published a paper 2 years ago called All Living Cells Are Cognitive, and he makes a very robust case that every single living cell, from the smallest archaea to protozoa and everything else, are cognitive beings. And I am defining cognition as the mechanisms by which animals acquire, process, store, and act on information from the environment, which include perception, learning, memory, and decision-making. And evolution is an active cognitive process. And an example of this is genome chaos. Henry Hang shows that cancer cells massively rearrange genomes at a high architecture level, not at a granular base pair level, but at the organization of chromosomes themselves in order to adapt to chemotherapy. And I show in my book, Evolution 2.0, that new species can be generated in weeks or months. And then there is self, non-self identification in bacteria. So bacteria know who they are, and they know the difference between themselves and their neighbor bacteria, and they talk to each other. In Shapiro's paper, he says cognition refers to the total set of mechanisms and processes that underlie information acquisition, storage, processing, and use at any level of organization. And cognition exhibits agency, which is exclusive to biology, and neither physical laws nor random interactions are able to make choices. And so we have this question: what does a cell know about itself? And Barbara McClintock asked that question in her Nobel Prize paper in 1984. And I think this is the central problem in biology. And it's really what we're talking about today. So the fifth unsolved problem in biology is that all artificial intelligence is artificial. Any 6-year-old can figure out in about 2 minutes that Siri or Alexa is as dumb as a box of rocks. Ginsburg and Jablonka wrote that general intelligence does not exist in machines. Animals have learning, universal adaptive learning, computers do not. And genetic algorithms always require goals from humans. I believe that if we understood biology, computers could be endowed with agency. And so, as an electrical engineer, I've investigated this, and I've identified 3 levels of causation in the universe. The first level of causation, the lowest level, is physics and chemistry, or physico-chemical laws. And these are things like matter, energy, light, heat, fields, waves, stars, and planets. And in this world, change over time is disorder, is order becoming disorder. It's ruled by entropy. The second level of causation is what I call computation, or code, or logic. And that's ones and zeros, it's genetic code, it's symbols, communication, computation, languages, machines, algorithms, and genetics. And these are freely chosen local rules. And when I say local rules, I mean that a Windows machine runs on one set of rules, a Mac runs on a different set of rules, and they are different rules, and they are local to the device that they operate on. Computation is deductive and it's deterministic. There is one output for one given input, and that's the definition of a mathematical function. And codes are subject to noise, which is information entropy, which is uncertainty can be introduced into a system, and once the uncertainty is there, it can never be reversed. Now, the highest level of causation is choice. Choice is defined as agency, action of self-interest, its meaning of messages, it's the creation of codes, and it's the highest level. And it sits at the top of these 3 levels. And cognition is inductive reasoning, which is choice within uncertainty. And the change over time with cognition is disorder to order, which is negentropy. And so conventionally, almost all scientific literature assumes that physical chemical laws give rise to code, which produces cognition. There, however, is no evidence anywhere in the literature that this ever actually happens. This is always assumed. It's never been proved. What I can observe in all engineering problems and all actual empirical data is that cognition generates codes which controls physical chemical reactions. This is how biology actually works. I don't know of any documented exceptions to date. I've written a scientific paper about this in Progress in Biophysics and Molecular Biology. I have a $10 million prize for anybody that can show that the version on the left is correct. And we announced at the Royal Society in 2019. George Church is one of our judges. He's a geneticist at Harvard Medical School. And this has been announced in Forbes, Inc. magazine, Voices from Oxford, Nature, Ecology and Evolution, the Financial Times, and several other journals. And I believe that we have gotten cause and effect backwards for 100 years. And so I want to dig into this by showing you a rigorous definition of the difference between artificial and natural intelligence, which of course is the title of this conference. What I have on the screen is a picture of a human looking at a calculator, asking the question, is the calculator going to arrive at an answer? And I've shown you the number pi, which, as most people know, has an infinite number of digits. And is the calculator ever going to get done finding all the digits? Now, mathematicians know it's not going to, because the digits go on infinitely. But the general situation of trying to figure this out is called the halting problem. Is the computer going to arrive at an answer? And we all experience this every day, because when we have the spinning blue wheel of death on our computer, or the blue screen of death, it means the computer got caught in an infinite loop and it may crash. And this is a normal part of computing every day. And it's called Turing's halting problem. And Alan Turing figured out in 1936, just conceptually, that this was going to be a problem when you could actually start building computers. And he discovered something very profound, which is that there is no algorithm or formula that can generally tell you whether the computation is going to arrive at an answer. It may get an answer, it may not. You don't find out until you run it. And you can't run an algorithm in advance that will tell you. Well, so as I began thinking about this, and when I was writing my 2021 paper, I needed a rigorous definition of both inductive and deductive reasoning. Now, it's very easy to find a rigorous definition of deductive reasoning. It's computation. By definition, that is what it is, and any mathematician can tell you that. But when I started looking for definitions of inductive reasoning, I found all kinds of answers. And the answers are usually somewhere along the lines of Socrates is mortal, therefore all men are mortal. That's a classic example. It's inference rather than deductive proof. Well, I came to the conclusion that a rigorous definition of inductive reasoning is asking or predicting whether a Turing machine will halt. And that is a cognitive activity which a computer is not capable of. A computer is not capable of wondering if it's going to solve a problem. A computer just obeys its program and either solves it or doesn't. But a human or an animal or a cell is capable of wondering, is the computer going to get to an answer? Is the machine going to deliver me some food? And it can consider the possibility that it is or is not true. And this is the difference between artificial and natural intelligence. If you're looking for a rigorous definition from mathematics, this is it. So you could say that intelligence is the ability to form beliefs about the outside world. So any cell that is sensing its environment, or any organism that is operating its environment, is using perception and is making decisions based on what it thinks will happen in the future, just like the human looking at the calculator is wondering if the calculator in the future is going to stop. And so the Turing halting problem is a question about the relationship between the past, the present, and the future. So inductive reasoning is Turing's halting problem. So this is the most important slide, I think, in the entire presentation. So let's go take this apart. What this means is that mathematics itself starts with induction. Now, you could define reductionist science as the attempt to reduce everything in the universe to a mathematical equation. Well, this means that's impossible. Biology cannot be reduced to mathematics because mathematics cannot be reduced to mathematics. What do I mean by that? The only way that you can have an axiom in mathematics from which you do computation is to make a choice. And choice is cognition. And cognition is not computation, which is really the title of my presentation today. Biology transcends the limits of computation. So I want to show you a number of things that are equivalent to this. If you apply Turing mathematics in Gödel's incompleteness theorem, all of the following are isomorphic in information theory: negative information entropy, assigning meaning to symbols, choices and goals, evolution, axioms in mathematics, consensus about the truth of scientific laws, and inductive reasoning, and Turing's halting problem are all the same thing. They are all choices in the face of uncertainty. And they are all cognitive behaviors. In Gödel's language, they are undecidable propositions, and those require goals. And so life and biology make decisions that are impossible to compute. Back to Barbara McClintock, she said a goal for the future would be to determine the extent of knowledge the cell has of itself and how it utilizes this knowledge in a thoughtful manner when challenged. So one of the devices that we use in thermodynamics is Maxwell's demon. Maxwell's demon is, so this is a refrigerator, let's say, and the temperature in both sides is the same. And Maxwell's demon says that if I have a little guy who can open a little door and let a hot molecule pass from one side to another and let a cold molecule pass the opposite direction, he can create a refrigerator and reverse entropy without generating energy. But upon further investigation, they found that it consumes energy to detect the motion of the particles, so there is no free lunch. You have to generate energy in order to separate hot from cold. And so you always have to plug refrigerators into the wall and consume electricity. But this led to many interesting thoughts about information, because what that meant is that if you're willing to consume information, if you're willing to consume energy, you can use information to reverse thermodynamic entropy. So you're going to have a net increase in energy, but you can turn disorder into order by exercising a choice. Well, what I'm showing you in this diagram is something that not many Maxwell's demon textbooks mention, which is, in order for Maxwell's demon to operate, somebody has to choose whether A or B is getting hot. And a choice is cognitive. And so once again, this is an example, a very rudimentary example of cognition turning disorder into order by consuming energy. Another way of expressing this would be that a Turing machine or a computer program only obeys the program that's been given, and that is deduction or computation. But what AI aspires to be is what I call a volitional Turing machine. It is a machine that reads a tape, it obeys its program, but at the last step, it can reverse a 1 into a 0 or a 0 into a 1 because it wants to. And it chooses whether to obey the program or not, and that is induction. Now, I wrote the world's best-selling books on Google and Facebook advertising, and I've spent the last 20 years of my life living in these worlds. And these platforms do not exhibit any form of cognition. They are just giant computers that are run by people. If the capabilities of Google or Facebook rivaled even that of a tiny colony of bacteria, the market caps of these companies would skyrocket overnight. That is to say, AI is all A and no I. It's all artificial and no intelligence. In short of identifying the undiscovered laws of physics that make cognition possible, Siri is not going to wake up anytime soon. And that is because neither thermodynamic entropy nor information entropy have goals, but negative entropy has goals and direction, which is teleonomy or teleology, which is multiple attempts at the same goal despite unpredictable obstacles. And so that means that negative entropy, as Schrodinger talked about, is really about information. It's not energy. Neg entropy is the increase of information, and it's measured in bits, which is standard in communication. And a coin toss is 1 bit of entropy. And then when you choose, like call it in the air, heads, that's a choice between 2 sides of coin, and that is 1 bit of negative entropy when that choice is made. Now, I have a proof here, and if somebody wants me to go through this proof, I'll be happy to. It's in my slides, and my slides will be made available to everybody. I sent them to the organizer earlier today. But I'm just going to talk through this very quickly. Math functions in computer programs are equivalent and deterministic. Deterministic Turing machines are deductive. Adding randomness to Turing machines generates information entropy, not neg entropy. And there is a severe limit on the size of useful statements that can be generated by randomness, which is really the computational explosion problem. Negative entropy requires agency. And this is a statistical, not a deductive proof, because the first code that we know of is the genetic code. And we don't know the origin of the genetic code. And there are 5 possibilities. The first possibility is that time travel is possible and humans designed the genetic code. I think most people would consider that to be absurd. The second possibility is that extraterrestrials designed the genetic code. Well, that doesn't really solve anything, even though it could be true, because it just moves the problem further back in time. The third possibility is the genetic code emerged randomly and accidentally. Well, this is not a testable hypothesis, and it violates the law of information entropy. Therefore, it does not qualify as science. The fifth possibility is that there is divine intervention. That's possible, and I believe in God, but I really don't like God of the Gaps arguments. And it also implies that codes create cognition, which I already have argued to not be the case. And so that leaves us with, there are unknown laws or emergent properties of physics and chemistry. And that is the subject of this paper, cognition and agency. Generating mathematical axioms is by definition inductive reasoning, which requires choice. And therefore, agency exhibited by life is not matched by computers. Therefore, biological systems are not Turing machines, and biology transcends the limits of computation. Again, this is a mathematical proof. It's not just an assertion. But there is this wiggle room. And the wiggle room is the issue of randomness, which makes this an inference, not an absolute proof, because maybe randomness could produce codes, or maybe randomness could produce cognition. This is why I have a $10 million prize. If there's any way for this to be violated, if there's a process like an undiscovered law of physics, we want to discover it. And if that is discovered, it's one of the biggest discoveries in the history of science. And so what this means, though, is that evolution is not random events, it's response to random events. And that evolution requires principles of cognition that we do not yet understand. So you can falsify my presentation with any experiment that demonstrates that chemicals produce codes with no assistance from biology, or any experiment that demonstrates codes produce cognition, again with no assistance from biology. So when Isaac Newton discovered gravity, he harmonized two things. He said, hey, you know that thing that causes apples to fall out of trees? It also causes the moon to orbit the earth. And so he brought together two things that people thought were unrelated, and they were really the same thing. And what I would like to suggest today is, what if negative entropy, origin of life, evolution, AI, and consciousness are not 5 problems, but 1 problem? And the problem is, what is the origin and nature of cognition? Well, this has implications. It implies that it's impossible to reduce biology to mathematics. It implies that reductionist methods will continue to fail in biology and origin of life, and in cancer, and many other fields. It implies that science itself has to be redefined beyond fixed laws in order for it to go forward. And it says that the soft sciences like sociology and psychology and economics and biology are richer than the hard sciences like chemistry, engineering, and physics. And it implies that there are missing laws of physics, but these are not like the prior Newtonian laws, but they are principles of agency. It suggests that your goldfish is smarter than Alexa or Siri, and that if any of you are familiar with Ray Kurzweil's concept of the singularity, there's no strong I and no singularity until this question is solved. And that this problem is really a quest for the next Nikola Tesla or Albert Einstein or Ramanujan. We're looking for that next genius. And these are my references. So I will be happy to take questions. So let's see what we've got.
Very Marcel, for your wonderful presentation.
When you talk, the audio is very bad. If you could lower the sound of your voice, it won't be as distorted and I'll be able to understand you.
Can you hear me clearly now?
It's a little distorted. If you talk a little quieter, it should be okay.
Can you hear me now? Can you hear?
Yeah, that's okay. Just talk softly and I can hear you.
Okay. Thank you very much for your wonderful presentation. So now the floor is open for questions and answers. Anybody have any questions for Perry Marshall?
I have a question if no one else has.
Yeah.
Also, Perry, can you please just stop sharing the screen also?
Oh, yes.
Thank you. So thank you very much for coming and for giving your very nice presentation. So you explained, although you're a theist, you don't like the gods of the gaps argument and that you want to take the path of science to answer these very hard questions, which is, great. Our institutes are very much aligned with that. So at the end of the presentation, you essentially said all these problems are one problem, not so many. And the ultimate question comes down to what is the origin of cognition?
Right.
So it's, I think, an a posteriori observation to say that cognition and consciousness is a symptom of life, because nothing which is conscious is not also alive. Right? Everything which is conscious, it must be alive. If it's not alive, it definitely can't be conscious. So again, of course, the idea of life is not so clearly defined, but we can also say that in nature, we only observe life coming from other life, right? From cells to organisms.
Right, right.
So then the question then moves to, okay, so what is the origin of life, such that the observation that life comes from life is an empirical fact. But life itself, as we observe it, does not demonstrate the capacity to be the origin of itself. It kind of leaves you with an infinite regression, if you're following that logic.
Absolutely. Yes, yes, yes. I'm totally tracking with you.
So that first life, if you want to stick with that word, has to be somehow the cause of itself. It has to be the cause of itself. And now both in Western philosophy and Eastern philosophy, these ideas have existed for a long time. Spinoza called it causa sui. In Vedanta, the scriptures called Krishna Sarva Karna Karnam, the cause of all causes. So to me, this progression of logic seems very scientific and not a God of the gaps argument, because it's proceeded through necessity, starting from our own observation. So I'm wondering what your thoughts about this succession of logic is.
So what you're really saying is not different than the principle of biogenesis, which is life creates life, right? And so people have indulged in a certain amount of sleight of hand, just saying, well, there's going to be a warm pond and a lucky lightning strike, and the lucky RNA strand's going to get going, and then eventually consciousness will emerge. Well, so as an engineer, I observe that the causation flows from consciousness to chemicals, not chemicals to consciousness. So therefore, I think consciousness precedes matter and energy. This is what I think is, I think matter and energy are a consequence of consciousness rather than being a cause of consciousness, and I think this is the way around it. So how do we turn origin of life into a scientific theory, if that's possible? Well, I conceptualize that maybe life is more like an antenna, if I can use that analogy, that transmits consciousness rather than being the source of consciousness, and that there is some mechanism by which consciousness is able to physically interact with matter, and that is the problem that has to be solved in order to solve the information problem in biology. There is a mechanism. I have a friend named Bill Jenkins who's an engineer, and he defines the question as, what is God's transducer? And any engineer knows that a transducer converts one form of energy into another, like a speaker or a microphone. And so I'm using analogies to hint at what I think the solution looks like. And I have a presentation on my website called Ways to Win the Evolution Prize, in which I go through a series of questions that modern science has been reluctant to address that I think might have some solutions. One of the places where I think we need to look is in psi research, like telekinesis and precognition and things of that nature. There's 100 years of literature and tons of experiments, but the mainstream scientific community likes to pretend that none of that research exists. Well, we know that humans, by concentrating, can deflect the trajectory of falling balls. So that means that purely conscious activity has the ability to deflect matter. So what is the mechanism behind that? I'm not sure anybody knows. But in that presentation, I go through some of these mysteries. So does that start to answer your question?
It does.
We could listen more because the next speaker has to catch a flight. You have another short question from Dr. Alex.
Really wanted to congratulate you on a brilliant and originally perspective talk. I would advise you, this is not a question, it's a little comment. Look at complexity and fractal physiology, because within fractal physiology, you find instabilities, critical instabilities, which make biology completely incomputable.
Well, that's another problem. I didn't even get into the incomputability of chaos theory, but it's a different kind of incomputability. The incomputability of chaos theory and the butterfly effect is the impossibility of measuring and detecting with sufficient precision to predict that the butterfly wing here is going to make the hurricane over there. And so that is a problem. But I think the cognition problem is a different kind of problem. And it's the fact that inductive reasoning is by definition non-computable, but people do inductive reasoning all the time. So I think these are two different levels at which the deterministic Newtonian models of the universe break down. And thank you very much for your comment. I very much agree with you.
Thank you very much, Puri, for your nice presentation. So because of the lack of time, we could not interact more. It would have been more interesting to have more questions, but we thank you very much for your very nice presentation on the topic.
Thank you for having